Now in this video, we've got to determine whether these lines, these four lines, intersect the circle with equation x minus 1 squared plus y plus 3 squared equals 10. And for any of these that do, we want to find the coordinates of the points of intersection. So we're going to start off with y is equal to minus 6.1. Now whenever we're doing intersections, we're going to be using simultaneous equations. And for all four of these, I'm going to be substituting these equations into that one. Okay? So, when y is equal to minus 6.1, we've got x minus 1 squared plus minus 6.1 plus 3 squared equals 10. Okay, so minus 6.1 plus 3, square that. Okay, so I've got x minus 1 squared plus 961 over 100 is equal to 10. So if I subtract the 961 over 100 from both sides, I get x minus 1 squared is equal to 39 over 100. Okay, then I want to square root both sides. So x minus 1 is going to be equal to plus or minus the square root of 39 over 100. Okay, so well, that just gets me plus or minus root 39 over 10. Okay, so then you can add 1 to both sides. And there you have the x values. Okay, so yes, the line y equals minus 6.1 does intersect the circle, and it intersects the circle at 1 minus root 39 over 10 minus 6.1 and at 1 plus root 39 over 10 minus 6.1. So they are the two coordinates of intersection. So if we have a look at number 2, we've got this y equals 1/2 x minus 1. So substituting it straight in, x minus 1 squared plus 1/2 x minus 1 plus 3 squared equals 10. So x minus 1 squared, let's simplify this bracket, so 1/2 x plus 2 squared equals 10. So I'm going to want to expand this bracket out, or both of them. So x squared minus 2x plus 1, that's the first bracket. Then for this one, we'll have 1/4 x squared. Then 1/2 x times 2 is just 1x. Going to happen twice, so we've got 2x. And then we've got 2 squared, so 4 is equal to 10. So if we tidy this up, we've got x squared plus 1/4 x squared, so that's 5/4 x squared. We've got minus 2x plus 2x, so they cancel, they can go. And then we've got 1 plus 4, which is 5. And then take that 5 from both sides. Okay, so we're just going to have 5. So if I multiply both sides by 4, I get 5x squared is equal to 20. So x squared will be equal to 4. So x will be plus or minus 2. So when x is positive 2, the y value is 1/2 times 2, take away 1. So 1/2 times 2 is 1, take away 1 is 0. And when x is minus 2, I get 1/2 times minus 2, so minus 1, take away 1, so minus 2. So minus 2, minus 2. Okay? And that is the pair of coordinates for where this line intersects the circle. Now let's have a look at number 3. X equals 4.4. Okay, so that is a vertical line at x equals 4.4. So substituting it straight in, we get 4.4 take away 1 squared plus y plus 3 squared equals 10. So 4.4, take away 1, square that, so we get 289 over 25. Right, now if we subtract the 289 over 25 from both sides, 10 take away that is minus 39 over 25. So, herein lies a problem, okay? Because we cannot square root a negative number and end up with real values. So there are no real solutions to this equation. And so x equals 4.4 is a horizontal line that does not intersect the circle, okay? Because we've ran aground with our algebra here, that has the consequence of contextually meaning that they do not intersect. Okay, so number 4, y equals minus 2x plus 7. We're going to substitute this equation straight into the equation of the circle. So x minus 1 squared plus minus 2x plus 7 plus 3 squared equals 10. So if we tidy up that bracket first before expanding it, we're going to have minus 2x plus 10 squared equals 10. Right, now we're going to expand both of those brackets. So this first bracket is going to expand to x squared minus 2x plus 1. Now this second bracket, we've got minus 2x times minus 2x, so 4x squared. We're going to have minus 2x times a 10, so minus 20x, but that's going to happen twice, so minus 40x, and then plus 10 squared, so plus 100 is equal to 10. Right, so now what have we got? We've got the x squared and the 4x squared, so 5x squared. We've got minus 2x, take away 40x, so minus 42x. And we've got the 1 plus 100 is 101, but then we've got to subtract 10 from the other side, so plus 91 is equal to 0. Right, so now with this quadratic, you could quite easily just substitute this into the polynomial solver, quadratic solver. So 5 minus 42, 91. And you'll get 21 plus or minus root 14i over 5. Now that I means we've got imaginary roots there. So we've actually got complex numbers coming from this. So we do know that there isn't going to be an intersection between this line and the circle, but we don't really want to write it down that way because it's out of the spec. So really what we want to do is we want to explain it using the discriminant, because if the discriminant, that part that's underneath the square root sign in the quadratic formula, if the discriminant is negative, then that means we would be square rooting a negative number, and that means that we would get these complex numbers coming. So we just need to show that the discriminant is negative, and that will allow us to say that there are no real roots. So we can say that the discriminant, b squared minus 4ac, is equal to minus 42 squared, take away 4 times 5 times 91. Okay, so minus 42 squared is 1764. And then we've got 4 times 5 times 91, which is 1820. So you actually want to work that out. So that's minus 56. And then you can say, right, well, that's negative. Therefore, there will be no real roots. Okay? And so the line and the circle do not intersect, because that equation there has no real roots.